Alright, today we're looking at Math 2, Unit 3, Lesson 3. This is, again, Form K. It's the form we are using in Buchanan High School. And so we're looking today at triangle congruence by the angle-side-angle or the angle-angle-side postulates. Alright, the previous lesson was on side-side-side and side-angle-side. So now we're adding to our collection of postulates with two more today. So here we go. First off, we have to take a look at some triangles, and it wants us to name two triangles that are congruent by angle, side, angle. So when I look at the little choices they gave me here, which I'll zoom in a bit more, a little tricky to see here, I have a 1 and a 1 and a 1. Oh, that's great. I have a 1, 2, 1, 2, and oh, those aren't quite matching, are they? I should have my congruent line segment in between the two angles that are congruent. So I would say here that triangle, and I want to write my order the right way. Okay, so I'll start with my single angle here. RQ, going this way, double angle, S, no mark, is congruent to triangle, single angle, T, U, and V. Alright, moving over to number 2. Same idea here. Again, I'm going to look at it, figure out which ones match, and I'm going to line that up and write it out in the correct order. So I'm going to let you do number 2 and number 3 on your own because I think you can figure those ones out without a lot of difficulty. Alright, let's look at number 4. Number 4 is a proof problem. Again, not always my favorites. I was never great at proofs growing up as a kid, but here I am back doing them once again. Who knew? So here we go. They always tell you what's given, and that's where you begin. Your given information is the first thing you put in your proof statement. The last thing we'll put in our proof statement is what we're trying to prove. We're trying to prove that in this case here, triangle ABD is congruent to triangle CBD. That's our goal. So let's see how we get there. It's nice that they give you kind of some steps along the way. It helps you figure out what's going on. So first we have that BD is perpendicular to AC. So this line is perpendicular to AC. They also tell us that BD bisects angle ABC. That means that right here, because it's bisecting, this angle will also equal this angle. They're going to be the same measurement because it's bisecting the angle. That's some good information there. So let's see what I have. I have my given, and I write that down. It does say here my reason is definition of perpendicular. So I have to think back, well, what does that mean, definition of perpendicular? Well, that means that because it's definition of perpendicular, they're telling me that angle ADB is a right angle, as well as angle DB, ADB is a terrible D, is, and CDB, angle CDB are right angles. Alright, so because they're perpendicular, I get right angles. So that's check. So I have my angle there. Check, check. I got an angle. Then we have ADB is congruent to CDB. So ADB congruent to CDB. A little bit like yesterday. We already kind of look and say, yeah, it's true, but I have to state it in my reasons as well. Make a statement. And that's true because why? Just like yesterday, all right angles are congruent. So that we're just saying those match, we're okay. The next statement is ABD, so this one is congruent to CBD, here and here. We mentioned that earlier, that's going to be true, and the reason that's true is the definition of angle bisector. So when you bisect an angle, by definition, they're going to be two equal parts. So that's that one there. So that's my angle. All that's missing is this side. But I know that it's going to be equal because of the reflexive property of congruence is going to tell me that this is the congruent side. Now I just have to state it in my statement. So I can say BD, or line segment BD, of this triangle is congruent to BD, the same BD of this triangle. And that's all we're saying. So now that I have an angle and a side and an angle, I can say that triangle ABD is congruent to triangle CBD, and then we're done with number 4. Okay, let's take a look at number 6. And I really want to stress it's important that you learn these little things. Make some flashcards up if you haven't done that already, so you're keeping track of them as we go along. I have mine written down in a little notepad, and I just refer back to them as I'm going through these assignments. And it helps out quite a bit. Okay, so now we have KJ is congruent to MN, so this is congruent there. Angle KJL is congruent to MNL, so there and there. And we want to prove that the two triangles are equal. So here we go, step by step. So we write down the given, perfect. They give me a clue here. They say that KLJ, this angle, we'll put 2 lines here, is congruent to MLN, here and here. And we know that's true from several other problems we've done this year already. These angles here are what we call vertical angles. So we're simply going to say the reason those are equal is vertical angles are congruent. And we've seen that many times so far already. Now they tell us the third angles theorem. Third angles theorem, that's from back from, I think, one of our first lessons. The third angle theorem says that if I know 2 angles, then I can figure out the third angle. Now, since these triangles so far share similar first and second angles, that's going to mean the third angles are going to be equal to each other, because there's nothing else it can be. So we would say that triangle, here, watch your order. I'm going to go ahead and start with my one at the vertex here. I'm going to go LKJ, so triangle LKJ is congruent to LMN, triangle LMN. As a result of that, I know that I have angles that match. I have an angle side angle that matches. I see they want me to use the angle side angle theorem, so we're going to go with the angle side angle postulate, to prove that triangle JKL is congruent to triangle NML. And that's what we do for number 5. Okay, let's take a look at the next one. Next page, flipping it over, some more proofs today. Looking at number 6. For number 6, again, we have the given information, and this time they don't give it to us in the T chart, so I'm going to write it down. My given information is that PT is congruent to RS, and I have angle PTR is congruent to angle RSP. So it's not very neat, but all I do is I'm just copying that to that space right there. That's it. Okay? So we're saying PT equals RS, and we're saying this angle here equals that angle there. Make it a little darker for you. That's what we're saying so far to be true. Next it says that PQT, we can already kind of guess where this is going, this angle here is equal to RQS, just like the problem we just finished on the other side of the page. That's true. Remember why? It starts with a V. Vertical angles are congruent. You just get the habit, get the hang of it. It's the same thing again and again and again. Okay? What's interesting this time is, instead of having you use the third theorem, the third angle theorem to go, oh, now that one has to be equal there, and go angle side angle, they're saying, oh, we're okay. We have a theorem, or postulate, that angle side tells us they're going to be equal. So if I have angle side, then I'm good and I'm all done. I don't actually need to use the third angle theorem. Just kind of go with it. Say, okay, so PQT is going to be congruent to triangle RQS. And that's all I do for number 6. It's just strange. I'm not sure why sometimes they have you do the third angle and not. It's just what they do there. All right? It kind of tells you there's sometimes a couple different ways to get to your proof statement. So it's up to you which way you want to go sometimes. I like that they guide you, but they don't always. But that's okay. Number 7. All right, here we go. It says given. In this case here, I have my given BD. This line is the angle bisector of ABC and ADC. Okay, so first thing I need to do is I need to rewrite all of this stuff on line number 1. Okay? I'm not going to do it. Yeah, I'll do it. I don't know. So BD dot 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 is the bisector of that and that and that. And the reason is it's given. Okay, moving on. So because they're bisecting each other, there's a few things that I do know. I know that this angle is going to be congruent to this angle. Okay, so angle, I have to write this right, A, B, and come all the way down, D, is congruent to angle CBD. I also know that down here, because it said it bisected this one down here, this angle is equal to this angle. So ADB, so angle ADB, is congruent to CDB. Okay, that's kind of small to see, on a lot of space there. Okay, so we're saying this angle matches that angle, and that angle matches that angle, and that's the definition of the angle bisector. The next step, they tell me, or the statement is going to be that BAD is congruent to BCD. So if you look, because I have this angle and that angle, let's think about it as this triangle right there, okay? I have one triangle and I have another triangle. Because I know the top triangle, I have two triangle angles there, I can safely say with the third angle theorem what that triangle is going to be there. So those these angles are going to match each other. So this is the third angle theorem, which we didn't use in the previous proof. But here it is in this one. So we have a third angles theorem that shows that those angles are the same. We also know that this line is shared by both triangles, BD, and when they share that line, we call that the reflexive property of congruence. So the reflexive property of congruence there. So in this case, now I have an angle, I have a side, and I have an angle, or I have an angle and a side. However you want to do that there. In this case here, they go with angle, side. So let's run with it. And we will say triangle ABD is congruent to triangle CBD. As far as I can see, the reason that they do that, sorry about the picture there, is because we were trying to start with this letter A and go there, it meant that I needed to find angle measurement A and make sure it matched angle C, which is why we went ahead to the third angle theorem. When I think back to the previous question, that doesn't quite follow suit, but it's good enough for now. Okay, let's look at number 8. Number 8, reasoning. There we go. Student tells you that he can prove the angle-angle-side theorem using the side-angle-side postulate. Okay, and third angles theorem. Do you agree with him? Explain. Well, he wants to prove that he can do angle-angle-side using the side-angle-side postulate and the third angle theorem. Here's the problem. With a side-angle-side, how am I going to get a third angle? The third angle only works if I have two of the sides already given. I don't have, I've tried 2 angles already given. I only have 1. Because I only have 1, I can't use the third angle theorem, so I'm stuck there. I have to have 2 pairs of corresponding sides. I have to have, another angle in there. It's just not going to work. So the answer there is going to be, nope, can't do it. And then finally, the last one, can you prove these triangles are congruent? They really look like they might be, right? I can look and say, well, I have a segment matches and matches there. I have a segment here and here. That's great. I have angles, oh boy, and I have angles side to side. What's the thing you can't have? You can't have an angle side to side. It's not going to work. And the reason is the angle has to be included. Okay, so it's going to be no, because there's no angle included. Okay, the angle has to be included in order to use one of the theorems. That's why we had angle side angle, right? Or we had angle angle side. So lots of options there. Yesterday, side side side, and yeah, side angle side. But we can't do angle side side. Doesn't work. Sorry. Okay, great. That's it. Have a great day.